Today's the big day. We are learning factoring quadratics. Quadratics are trinomials. This is one of the biggest skills you'll ever learn in algebra. Just think of a lot of things in life that you do, such as maybe you go outside and you play soccer. And you're out there and you're playing soccer, and you kick the ball in the air, and you want to know where that's going to land. Well, you don't have to guess where that's going to land. This is actually being modeled by a curve, and what we're working up to is you can figure out where these points are exactly at a certain time. Well, we're getting there. Not today, but eventually you'll be there. So a quadratic is just a special name for this very special quadratic form. That is ax squared plus bx plus c. So it's a trinomial with the x squared, the x, and then the constant. And then a, b, and c are always just numbers, all right? Those are going to be important to us. Let me give you a kind of brief survey of what we're going to be doing. We're going to be given trinomial in that quadratic form. We're going to split the b term up, and then we're going to do some factor by grouping. Notice what's happening here. Pulled out our x, had an x plus 2 left over. Pulled out our 4, had the x plus 2 left over again. So we have two factors, the x plus the 2, and then the leftover stuff on the outside. All right, now why are we having to split this term? Well, that goes back to when we were double distributing, FOILing. So if I gave you those two factors, or asked you to find the product of them, what you would do is you would say, all right, I will take x times x, and say x squared, and then I'd say x times 2, which is 2x. Hey, look at what they have right here. And then you would say 4 times x, say 4x, and 4 times 2, which is 8. Hey, look at what's over here. So what happened is when we were multiplying these together, we would always end up with these like terms in the middle that we would stick back together to get that trinomial. Now that we're trying to factor, we have to break that middle apart again. That way we can find the two factors that went into it. So keep that in mind as we go through these problems. So here's how you know what to break that into, because you can't just randomly do it, or else these nice little partners aren't going to fall apart like that. So take a look at our first example. Remember your quadratic form that we were talking about, ax squared plus bx plus c. And the first thing you should do is pull out what a, b, and c are, what numbers they are. So a is in front of the x, so 2 in this one. B is in front of the, a is in front of the x squared, b is in front of the x, which is the 7. And then our c down here is 6. So we've got this nice little x right here, and I don't know if you can read it. It might be a little too blurry for you. It says which two numbers, ... multiply to a times c, but add to b. That's how you break it up. So the first thing we have to do is take the first and the last, multiply them together. 2 times 6 is 12. And then we've got that b, 7. And we've got to figure out which two numbers multiply to the 12, yet still add to 7. That's the key to making this wonderful pattern up here happen. So if you need to, what I would always suggest is go to 12 and think of everything that multiplies to 12. Start with 1. 1 times 12. 2 times 6. 3 times 4. 4 times 3. See how we're repeating in the opposite order now? So you're done. We went through everything that goes to 12. Now add those together. See if any of them add to 7. We get 13. We get 8, and we get 7. That's the one right there. So 3 and 4 were our answer, and that's what we're going to break apart that middle term into. Now, the order doesn't really matter, but if you think about it, it's just easier to put a 2 with a 4 because it's really quick to think of what factors they have in common. Just like it's really easy to put a 3 with a 6 because it's easy to know what they have in common. So I've broken apart my 7x into two terms, and it's time for factor by grouping. So take out your GCF of 2x squared plus 4x. They both have, they're both divisible by 2, and they both have at least one x in common. When you pull out 2x, you have an x left over of that one because the 2's outside and one of the x's is outside already. The x is outside, and then 4 divided by 2 is 2. Remember to pull down your sign right here. And now 3 and 6 have a 3 in common. They don't both have variables, so we're not even looking there. So I have just that x left over, and 6 divided by 3 is 2. So I got the same thing there. Perfect. And that's my first factor. 2x plus 3 is my other factor. That's the stuff on the outside. So this and this. So that's back to factor by grouping. Another thing I want to point out, it actually doesn't matter which order you put these factors in, whether you put this one first or if you put this one second. Doesn't matter. Commutative property of multiplication says I can do either thing. Alright, so if you want to check that, all you have to do is FOIL it back together, double distribute, and see if you get out that original polynomial. We're going to save that for a later one. I want to get a little bit more into these. So do you think you know what to do yet? Let's try it out. So the first thing that you need to do for example 2 is pull out your a, b, and c. So your a is in front of your x squared, your b in front of your x, and your c in front of is that last thing, that last constant. Make sure if you have any signs in front here, you take those with you. Then you need to multiply a times c together. So 1 times 10 is 10. I know that didn't look like much happened because of that 1, but it did. And then down here we put our b, our 7. It needs to multiply to 10, but add to 7, your two numbers. So let's go and write a little tree and think of everything that multiplies to 10. 1 times 10, 2 times 5, 3 doesn't go in, 4 doesn't go in, 5, we've already written it, we found all the factors, not many. Now test those and see what they add to. We've got 11 and we've got 7. So the one we were looking for right there is 2 and 5. So take those two numbers and split up your 7. So I'm going to say my x squared. I would ignore your ninja. He's just getting in the way if you take him with you. You've got your 2x now and your 5x, and then that plus 10. So this 7x is still there. It's 2x and 5x, but we split it using this neat little trick over here so that everything factors correctly. Alright, let's do our factor by grouping. The first two things only have one x in common, nothing else. When you pull out that x, you've got an x left over and just a 2. Pull out your sign right here, goes down here. Now 5x and 10, both 5 and 10 are divisible by 5, which gives me an x, and 10 divided by 5 is just a 2 left over. That's perfect because that's what we got before. So the first factor is x plus 2, second factor is x plus 5. And that one is done. You found your factors for me. So if you wanted to check that, you would take it over here. And you would, again, double distribute that back, also called foiling. So x times x is x squared. X times 5 is 5x. 2 and x make 2x. 2 times 5 is 10. Put that back together and take a look. Perfectly factored because we got out the exact same trinomial we started with. Remember, these trinomials in this form have a special name, and that is quadratics. Let's look at example 3. Where do we start? A, B, and C. Here's our first negative popping up. So 1 is in front of your x squared. That's your b right there in front of your x, and your c is that constant at the end. So remember, take your first and your last, multiply those together. And then your b goes down here. We got to find things that multiply to 3 but add to negative 4. This can be a little tricky when they're that small, because you're like 1 and 3 and that's it. But now you've got to think of some other things too, because not only does positive 1 and positive 3 multiply to 3, but also negative 1 and negative 3 multiply to 3. So you only really need to think about opposite signs when you have a negative here or a negative up here. So this was the one we were looking for because this one adds to 4, this one adds to negative 4. So we're looking for negative 1 and negative 3. So let's take that up here. We've got our x squared minus 1x minus 3x plus 3. So I still have that negative 4x. It's just in two pieces now. This one you can take along with you. I think he'll get in the way again if you take him with you though. So what do x squared and 1x have in common? Just that x in each of them. And then that is an x left over with a negative 1 left over. Notice what I'm doing. Had 2, take out 1, so I have 1 left. Had negative 1, took out the 1x, only that x right there, so left over the negative 1 right there. Seems a little confusing because there's a lot of 1s in that one little area. Alright, over here, got that negative, so make sure you bring that negative down. Now what do 3x and 3 have in common? They both have a 3 in common. Now don't forget, you have to divide by negative 3 now. So negative 3 divided by negative 3 is just a 1x. Would not draw any of your ninjas through this. It doesn't help you anymore. And then 3 divided by negative 3 is negative 1. You did have to show that one because there was nothing else there to talk about. So your two factors, remember what you do. You take that repeating thing in your parentheses. And then you take this leftovers on the outside, and there you go. All done. All your factors done. If you want to check it, go to the side, double distribute it, FOIL it back out, and see if you get that original polynomial. Alright, I think this is our last example. So let's try it out. So our A is 3, our B is negative 10, and our C is 8. So it needs to multiply to A times C, 24, and it needs to add to negative 10, that B. So let's go over here and figure it out. We've got 24, but it needs to add to negative 10. The thing you know about this is they both must be negative then, right? If they multiply to a positive but add to a negative. So let's start it out here. Negative 1 and negative 24, negative 2 and negative 12. Ooh, that's close. That's negative 14. Negative 3 and negative 8. That's negative 11. Negative 4 and negative 6. That's the one. Those add to negative 10 right there. So negative 4 and negative 6. Again, it doesn't really matter which order you put it in, but when you're writing this, it just makes sense if you put the multiple of 3 on the side with 3, and if you put the negative 4 on the side with the multiple of 4. So I still have negative 10x. I've just split it into two sections. So it's time now to factor by grouping. So let's try it out. I've got 3x and 6x. I've got an x in each of those, so let's pull out an x, but also 3 goes into both 3 and 6. So when I pull that out, I've just got that lonely old x right there, and negative 6 divided by 3 is negative 2. My x is on the outside already. Don't forget when there's a sign right here to bring it right down here. And then 4 and 8 are both multiples of 4. So when I pull out that negative 4 divided by negative 4 is just that x left over right there. And then positive 8 divided by negative 4 is negative 2. That fixes the issue we were having with signs in our parentheses because these need to match exactly. So x minus 2 is one of your factors. The other one is the stuff left over. So 3x minus 4. Alright, one last time. Do you remember how to check it? You've got your two factors. Let's multiply them back together because factors should be multiplied back to their original form if it's right. So x times 3x is 3x squared. X times negative 4 is negative 4x. 2 times 3x is 6x. And then, oops, I'm starting with the wrong thing. I'm sorry, look at that negative. Let's just restart that. Helps if you start with the answer you got. Right here, x minus 2 and 3x minus 4. So x times 3x is 3x squared. X times negative 4 is negative 4x. Negative 2 times 3x is negative 6x. And negative times a negative is a positive. 2 times 4 is 8. So this is why we had to break it apart. We've got these like terms that have to go back together. And now we've got the same polynomial we started with, especially now that we started with the right factor. All right, thanks for listening.